So molo kunjani, sawubona, dumeleni, dumela, mambo, niaje, what's up, salam alaikum. I don't know if I forgot anything, uribo. See, so all them. So just forget one of them, please. Don't get mad at me. Question number 7 done already. Question number 8.1 done already. So question 8.2. So question 8.2, let me put it closer. How they say? They say show that the above equation have the irrational roots. Okay, so if the base is changed and so okay, so if this equation show that this equation have irrational roots if the base changes from 2 to 4. 2 to 4. Excuse me, 2 to 4. Yeah, so 2 to 4. So let's get to okay, so that's a question right there. Excuse me. So that's a question right there. So let me go straight away without wasting time. So let's say face the base of change show that the equation have irrational roots if the base changes 2 to 4. So I have to start facing on the base 2, take the equation, and then on the base 2, and then on the base 4. Remember, this is 8.2. 8.1 is done already. Check the previous question. So this is 8.2. So we're going to do the question solve in 8 in base 2. Same equation, we're going to put 2 2, and they're going to solve, and then we see also when is 4 4. That's how we say. Show that the equation have irrational root if the base change from 2 and the rational root if the base change to 4. So we know rational roots. We check on the previous question. For rational roots means excuse me, in discriminant it must be greater than 0 for any rational root. For rational root, so they want us to check root of roots. And discriminant must be greater than 0. Okay, so let's take a question. So we take a question, exactly, we copy. Think what the question say. Our equation say this one, excuse me, log x plus 3. So I'm going to recopy log x plus 3 right here. So say okay, so question log, and they say x plus 3. So now let's start with the base 2. So I'm saying that plus log our base is 2 for the first one equal to 1. So we want to see if this, so we know from the log rule, if it's plus and they have the same base, what we do, we multiply. So we're going to say log, and then we're going to multiply x times x plus 3. So it's x times x plus 3. Why? Because there's addition and the base are the same. Means there's a plus here and the base are the same. Please check previous question 8.1. You play on the same plan. I'll explain the same thing. Okay, plus minus. So say okay, so equal to 1. So now the base is 2. So we say something before. When do you remember? When do we apply exponential rule? We apply exponential only when you have a log on one side. We'll apply, so you want to have a log on one side to see of equal sign. So then you're going to apply exponential rule here. We're going to say exponential rule. How we say? These 2 is going to come here. It's going to come here. It's going to be 2, and it's going to push this one on top. It's going to be 1, and they're going to only write this one we left with, which is x plus 3, and the log is going to fall apart. So that's what we have. Log is going to disappear. It's going to be so now let's simplify. Multiply that in. It's going to be x squared plus 3x equal to 2. Take 2 over. So x squared plus 3x minus 2 equal to 0. So now we know from quadratic standard equation this is x squared plus bx plus c equal to 0. So what is our a? Our a equal to 1. A equal to 1. And what is a b? Our b equal to 3. And what is a c? Our c equal to -2. Semicolon here. Okay. So for our case now, for irrational, we know discriminant. My apology. Did I say determinant before? Discriminant. Just in case if I say discriminant, I'm apology. Discriminant, it has to be greater than 0. So what is a discriminant? Discriminant for irrational. Let me say here. For irrational, discriminant. It must be greater than 0, which is this one. So we're going to have to check if it's greater than 0. And the word discriminant means our discriminant meaning, excuse me, our discriminant we know for facts, our discriminant equal to b squared minus 4ac. So we want to check this if is greater than 0. So let's plug it in and see. Okay, how about b? B equal to 3 square minus 4 times a. What is a? A equal to 1 times c. C equal to negative 2. And then plug this, we're going to have equal to 9 plus 8, which equal to 17. And if c 17 is true, it's greater than 0. So for that case, 17 is greater than 0, excuse me. So we say, if this 17 is greater than 0, and then, for that case, so 17 is greater than 0. So for that case, 17 is greater than 0, and then yes, you're going to have 2 irrational roots. That's how we say, yes, since 17 is greater than 0, then we're going to have, we'll have 2 irrational roots. 2 irrational roots. Man, how would you know what are those irrational roots first? Explain to me, I don't understand. So look, how would you get root? Because remember, this is quadratic here. So let's make this one. So let's solve and see if it's true. Before even solving, we have already known that we're going to get 2 rational roots by just doing this one. So now let's see how we're going to get those 2 rational roots. So we know for the normal quadratic formula, we say negative b plus or minus, and then b squared minus 4ac over 2a. So let's see now. So x equal negative. What is a b? We want to see if the root is true, rational. B equal to 3, so say 3 plus or minus square root of b squared minus, but we have this, which is discriminant. What is that? 17 over 2 times a. What is a? A equal to 1. So can't you see this is rational because it's going to be x equal to negative 3 plus 17 over 2 or negative 3 minus 17 over 2. So we have 2 rational roots. See what I'm saying? So we got 2. Oh my goodness, it's not rational. You know why my problem is irrational roots. You know, say rational because rational, excuse me. Let's go. Rational, it has to be like 1 over 2 exactly. Let's say 5 over 3. So for this case, it's irrational. This is very important. It's irrational because it doesn't give us like 1 over 2. That's irrational. When you say, let's say 3 over 80, 7 over any number, let's say 7 over 9, these are rational. But when you have a square root of 5 over 2, this is irrational. Which is this one. So this, it gives us irrational root 2, but are irrational roots. You know what I'm saying? So when the base is 2, how to look? So we're going to say, okay, so our roots, when you say value of x means a root equal to negative 3 plus square root 17 over 2, and our value of x equal to negative 3 minus square root 17 over 2. So you see, we got 2 what? Irrational. Why we say irrational? Because of this stuff, we mess it up. Why? So we say if it's not perfect square. What is perfect square? Means when you square root, it has to be, let's say 6 3. That's a perfect square. So if it's even though this b square, which is discriminant, minus 4 is even though it's greater than 0, like we have seen in 17, which is greater than 0, but if you plug in here, it does not give us the pure number, like let's say 5 or 9 or 25, for example. Look, what is the perfect square meaning? For example, if you square root, let's say 100, what do you get? You get 10. So this is a perfect square. Or you square root, let's say 81, so when you square root, you're going to get equal to 9. So this is a perfect square. So for this case here, if you take your discriminant and plug in a root, it's not going to give you, because 17, there's no, we're gonna get a number, but it's not perfect square. If it was 25, yes, 16, yes. So that's what I say, these roots, there are 2 roots and equal, and you can see they're not equal because it's plus 17, but they are irrational. So we got 2 irrational roots when base is 2. When the base is 2, when base is 2, base is 2, we get 2 irrational roots. You can even say 2 unequal if you want. It's a very good word. I like this good word. 2 unequal irrational root. But from the question, how do I say? Excuse me. We come back to the question. show that the above equation have an irrational roots if the base changes to 2. Yes, we have shown when the base changes to 2, we have seen 2 unequal rational roots, and also has a rational roots. So now for the second one, I'll tell you the second one has a rational roots when the base is 4. Let's see now if it's true. When the base is 4, it's going to give us a rational roots. Let's go to the question. Excuse me, sorry. So we're going to solve the same thing now, but the base is going to be equal to base 2. Okay, so I'm going to turn this. Okay, base 2. So we're going to solve the same question, but the base now is going to be equal to 2. So the base is going to be equal to 2. So take the equation again. Everything's going to be the same, but the base is going to be equal to 2. Base equal to 2. Shows me I'm so happy. Okay, so let's go. So we're going to copy a question now. They say the answer now is going to be blah, 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 is going to be rational. That's how I say according to the question. If the base is equal to 4, let's take this now, put base 4 and see if it's true. It's going to be rational. Excuse me. So now copy my question right there. Let me use red pen. Every time I use that pen, let me use red. Use red. Quick. Let's go. Okay. I use this pen. Liam's pen. Okay. Liam. She sent me a marker pen, so we start to use one of the marker pen she sent to me. So we say my grade 6 student. They want to say, hey, me, your boring marker pen. Is a marker one of them? She sent to me. So we say x plus 3, and then we add log x equal to 1. So now what is our base? Our base is going to be equal to 4. They say we have to change base 4 and see if it's going to be rational. Okay, so now we know this from the log, since the base are the same, so I'll multiply this and that one. So it's going to be x plus 3 log and the base 4 equal to 1. And this exponential. Why? Because log is one side, so we push this one to the other side, 4, and this is going to go on top 1, and this is going to be x plus 3. So x squared multiply in, x squared multiply that out, so it's going to be 3x minus 4 equal to 0. Minus 4 equal to 0. So minus 4 equal to 0. Okay. So minus 4 equal to 0. And then we want to check the discriminant. So discriminant for either rational or irrational, both of them. So now we want to see if it's going to give us a rational. For either or both rational, for any to test rational or irrational, but for this case it's irrational, we know discriminant also must be greater than 0. Even if it's irrational, also must be greater than 0. Yeah, must be greater than 0, but a perfect square for rational. For rational, let me say here. Let me write here with the other pen. This is very important. For rational, discriminant must be greater than 0, but this discriminant must be perfect square. That's the difference between this and the previous one. See, for irrational, mean discriminant must be greater than 0, but this discriminant is or should not be, is not perfect square. Not perfect square. For irrational, not perfect square. So for this case now they say we have to test irrational, means is discriminant greater than 0, and there must be perfect square. Let's see. Now b square, which is discriminant minus 4 ac, we want to see if it's greater than 0. Let's see. What is a b? B equal to 3 square minus 4 times a. What is a equal to 1 times c equal to negative 4. So we have a 9, negative and negative plus 16, which equal to 25. Yes, so our discriminant is greater than 0, but it's also perfect square. Perfect square. So if it's also perfect square, excuse me, then it's going to be rational. What do you mean, brother? What do you mean about that? Let's plug in a quadratic. Now we say our roots, normal roots. How we get normal roots? Negative b plus or minus. We want to see the root if it's rational. B squared minus 4ac over 2a normal quadratic. So it must be rational, not irrational. So negative b. What is a b? B, 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 and then you have them here. Okay, B. So B equal to 3. So 3 plus or minus square root 3 square 9 minus 4 times A. What is my A? A equal to this one 1 times C. What is my C? C equal to negative 4. So negative 4 over 2 times A. A equal to 1 if I'm not mistaken. Yeah, equal to 1. But this is a discriminant, so I don't even know why I have to do all this again. Crazy. Okay. So discriminant, equal to 25. So which is this one, discriminant? So put 25 there. So it's okay. And they want to see the root. So say x equal to. Let me finish your red pen. It goes. It's dangerous. So negative 3 plus or minus. That's going to be square root of 20. 5 over 2, which is negative 3 plus or minus square root of 25 equal to 5 over 2. So you see your answer is irrational. You know why? Because it doesn't have those square root and all this stuff. It's perfect square. When you square, you get perfect number, like number, perfect. So we say x equal to, which are root, negative 3 plus 5 equal to 2 over 2 equal to 1. And negative 3 minus 5, negative 8, divided by 2 equal to negative 4. Negative 4. No. So we need to show it's irrational. So this is normal number. So it's okay. So the face value of x equal to negative 3 minus 5. It's negative 8 over 4, which you see is rational. Yeah, I think I got it, man. This was perfect, my apologies. 1 and 4, because negative 3 plus 5 equal to 2. So the face value of x equal to 2 over 2 equal to 1. And negative 3 minus 5 equal to negative 8 over 2, negative 4. So these are rational number, because when you say 1 means if you want to put in rational, it's like 1 over 1. Also say rational because number of a number. And if you say negative 4, you can say negative 4 over 1 is already in rational. That's what I say yes. So it's true that when the base equal to 4, the roots are rational. The other one, when x equal to, we have checked the equal to by final answer, x equal to 1 and x equal to 4. Okay, now we go to the question 9. Thank you very much for your question. So if you have a question, you can send it to me. Of course, you learn a lot from me. If you have a question, just ask me. Send a question. Okay, and leave the comments. Don't give me credit unless if the credit is you, and then you could. So thank you, man. If you think the video help you, you can follow me on Twitter. All the videos on my Twitter, Mtwana Wabantu Academy. You can get me there. Thank you.